This section is talking about dilations, and probably the most easiest thing that comes to mind when I think of dilation is like when you go to the eye doctor and they dilate your eyes, which means that your pupils they get really wide, so that they can see in. Well, that's really what a dilation is. It's a form of transformation where an object maintains its original shape, but it's either increased or it could be decreased in size. So you can think of blowing up a picture or dilating your eyes, blowing up your pupils. Or you can also think, though, about shrinking it in size. And that would also be a dilation. How much we increase it or decrease it by, we call a scale factor. Now, if you think about for just a second, if we have a picture its original size and we were to copy that its original size, we would say that that would be 100%, because it would be its original. The original size is 100%. If I wanted to blow it up, though, I'd have to increase it to like 200% if I were going to put it on a copier or something and blow it up. Well, 200%, it's just like with everything else. We talk about percentages, but we always work with fractions and decimals in our mathematics. So if I were to blow something up 200%, that would be like twice its original size. So that would have a scale factor of 2, meaning that it's 200% of its original size. Now, we could also shrink things down. If you think about making something 50% of its original size, wouldn't that be half as much as it was originally? Absolutely. So that scale factor would be a half. So when you're looking at scale factors, anything over 1 is an increase in size. Anything under 1 would be a decrease in size. So let's look at this example. It says, in the following drawing, find the image of triangle ABC under the dilation with center 0 and scale factor of, that should be a 2/3. So we have this triangle here, ABC, and it's centered here at 0, at O. So there's its center. So we're going to dilate this thing by a factor of 2/3. Okay, so to start with, is that going to increase its size or decrease its size? It's going to decrease it because 2/3 is less than 1. So that would be about, what, 67%, something like that. So we're making it smaller than its original. So just think about taking that triangle and shrinking it down smaller than what it already is. It would look something like that, right? Well, they're using red, I use blue, but so it has to be this part B. We could eliminate C and D from the beginning because that's blowing it up. That's increasing the size of the original triangle. And also A will not work because the center is not here in the original triangle. They've translated it, moved it over just a little bit. All right, let's see what else we have that we can do here. Okay, this one says, in the following figure, a smaller triangle is the image of the larger triangle under a dilation centered at point 0, or O, rather. Okay, so what that means is they've taken this triangle, this is our original triangle, and they have performed the dilation and gotten the smaller triangle. So what does that tell us to begin with? That tells us that our scale factor is going to have to be less than 1. Well, we can find our scale factor by looking at the ratio of those sides that we know. For instance, the side here of 6 corresponds to this side of 8. So if I put 6 over 8, that would reduce down to 3/4. That's our scale factor. And you'll know that you're right because it's less than 1. If we had done it backwards and we had put 8 over 6, then that would be a scale factor of 4/3. That would be blowing it up, not reducing it down. So that would have been incorrect. Once we know what our scale factor is, we can now find side x and side y because we know what proportion these sides have to be in. For instance, the relationship here for side, let's do side y first. The relationship of side y compared to 10 has to be that 3/4. So now we can solve that equation. We can multiply both, we can cross multiply to get 4y equals 30. And then if we divide both sides by 4, we get y equals 30/4. And then if you want to, you could go ahead and use your calculator to figure out that that's y equals 7.5. Now we could also go through and use the same procedure to find x. Side x compared to side 12 has to be that same proportion of 3/4. So now when we cross multiply, we would get 4x equals 36 or x equals 9. All right, and our last couple of examples are very similar, but I wanted to look at both of them because it kind of looks at things two different ways. This one says the following describes a dilation with center O, an image of the segment of length 12 in blue. So that means that this starts off with this smaller triangle here. And you know what? I'm just going to take that smaller triangle and draw it right out here. So the smaller triangle is side 16, side 12, and side 20. And then the image, it's blown up to make this larger triangle. And this larger triangle has this side x. This side is 20 plus y because we'd have to add both of those together to get that side. This bottom side here is going to be 16 plus 64, which is 80. So that's what we're really looking at, those two different triangles. And now, because this is a dilation, then those triangles are they're similar triangles, which means they're in proportion to each other. So now we can use proportionality to go ahead and to solve for x and for y. So if I look at this and I want to compare sides, well, the two sides with plain numbers are the ones we want to compare. So since I'm blowing this up, I want the bigger number to be on top of the smaller number because I want this scale factor to be over 1. If I were shrinking it down, I'd want it to be under 1. So I would do it backwards. But because we're blowing this triangle up, our scale factor should be greater than 1. So I'm going to take the 80 and compare that to the side 16. And when we do that, when we divide, we end up with 5 as our scale factor. So that means that each one of these sides is 5 times each one of these sides. Well, that helps us to be able to figure out x very easily because we know that x here is going to equal 5 times this side of 12. So that means that x has to equal 60. And we can also figure out what this side is, what y would be, because we know that this side here of 20 plus y has to equal 5 times that original side of 20. So that means that 20 plus y has to equal 100. And if I scoot the 20 over, subtracting both sides by 20, we get y equals 80. So now we know what all of our missing parts are. Let's try one more like that. Here we have the figure describes a dilation with center O, and the image is in blue. So that means that we're starting off with our smaller triangle here, and that smaller triangle is X, Y, and 12. And we're blowing that up to get the bigger triangle, which the bigger triangle would have this side here would be Y plus 60. It would have this side here would be X plus 36. And then, of course, this side here is 60. So again, we want to compare the numbers that we have, and because we're blowing this up, we want a scale factor of greater than 1. So I'm going to take the 60 and put it over the 12 so that we get a scale factor greater than 1. And when we divide 60 divided by 12, again, we're going to get a scale factor of 5 in this case. Scale factor. So that means that each one of these sides is 5 times each one of these sides. Well, and again, we can use that to figure out what x and y are, because we know that this side here, the x plus 36, has to equal 5 times that original one of x. So whenever I subtract x from both sides, we get 36 equals 4x, or x equals 9. If I want to find out what y is, y plus 60 has to equal 5 times that original side of y. So when we subtract y from both sides, we get 60 equals 4y, or when we divide both sides by 4, we get y equals 15. And so we've used those properties of proportionality in similar triangles in order to solve those triangles.